Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
We copy you down, Eagle. Listen, Tranquility Base here. The Eagle has landed.
There is a small planet so near the sun that it is scarcely visible in the bright glare of our star. Like an elusive ghost, it is best observed from Earth in the twilight hours, when the sun is gone from the sky. The ancient Romans gave it its name, Mercury. So little was known about the planet that scientists could only guess at its origin and evolution. Like the planet Mars, it could have had violent volcanoes, deep canyons scarred by violent winds, or like our own moon, its surface might be pitted with craters, a record of ancient events written on a planet's surface. The best photographs of Mercury added little to our knowledge. But when man learned to travel in space, the electronic cameras of a spacecraft called Mariner 10 revealed the planet in startling detail. In June of 1975, scientists from 5 nations assembled at the California Institute of Technology to exchange the information they had gained from the exploration of the planet Mercury by the spacecraft Mariner 10. Included in the group were scientists representing many techniques of exploration, including the detection of various forms of radiation, the study of gases in a planet's atmosphere, and the powerful scientific tool, photography of the surface of a planet.
Welcome to Pasadena. We are convened.
The photographic exploration of Mercury was led by Dr. Bruce Murray of the California Institute of Technology.
The objective I have is to present a relatively simple interpretation of the history of Mercury and to draw some conclusions about the other terrestrial planets.
The work that Dr. Murray and his colleagues are engrossed in goes beyond the exploration of a single planet, Mercury. They are seeking insights into the history of our entire inner solar system. The search for new information began with the launch of Mariner 10. These photographs of the Earth were taken to test the cameras that were to photograph both Venus and Mercury for the first time. After leaving the gravitational field of Earth, Mariner 10 began its long voyage to Mercury. The spacecraft's flight path was carefully chosen to skim past the planet orbiting between Earth and Mercury, cloud-covered Venus. The Mariner 10 cameras at close range were to show us a startling new Venus, a Venus we couldn't see from Earth.
Venus has been a real frustration to photograph from the ground because in the visible it's perfectly featureless. There is occasionally a little bit of indentation along the terminator, and occasionally one can see a little structure around the limb. But basically it appears from the Earth to be obscured by an incredible haze. In the ultraviolet, however, That's the wavelengths beyond the blue that the eye cannot see, but photographic film can respond to. Very faint markings have been observed. And it was those faint markings in the ultraviolet that persuaded us to make a maximum effort to photograph Venus in the ultraviolet up close.
The Mariner 10 cameras photograph Venus in high-resolution sections, each photograph covering only a small portion of the planet. The frames were then pieced together into mosaics to give a detailed picture of the entire planet.
The results of the Mariner 10 photography in the ultraviolet were really good. In fact, much, much better than we had hoped. Because, as you can see, looking at first a picture of Venus in the visible that was taken by Mariner 10, and then when we switched to one that was taken in the ultraviolet and has been enhanced with a computer to bring out the details, there's a tremendous pattern of organization of markings. Let's take a look at what's in these pictures. The most prominent thing that one can see is a very bright south polar cap, probably a great vortex, almost like a huge cyclone. And there are dark streaks that come into this as though they're winding up like taffy. So the whole series of mosaics was like a series of snapshots of Venus in time. And from those mosaics, it was possible to create a time-lapse movie of the rotation of the Venus atmosphere during the period of time Mariner 10 flew by and flew away from the planet. The pattern of rotation of features on Venus in the upper atmosphere, way up high by our standards, is remarkable in that the atmosphere on Venus rotates faster than the surface. In the case of the Earth, the atmosphere tends to drag behind a little bit, as one might imagine. In the case of Venus, the atmosphere rotates all the way around the planet once every 4 days. The surface rotates once every 243 days. So the atmosphere is rotating almost 60 times as fast, at the top anyway, as the planet itself.
The gravitational field of Venus was used to bend the flight path of Mariner 10 inwards towards Mercury. Then the gravity of the Sun pulled Mariner towards its first encounter with the planet. In March of 1974, Mariner 10 flew past Mercury. During the next year, it would perform 2 more flybys.
Mariner 10 returned almost 3,000 pictures of the surface of Mercury. These pictures reveal craters and other features which were formed very early in the history of Mercury and may refer to events that affected the entire inner solar system, Mars, Earth, Moon, and Venus, as well as Mercury. The pictures of Mercury reveal craters and many other features. And to the geologist, these features and these pictures are like the pages of a history book. And the history book for Mercury may go back almost to the formation of the solar system itself.
$5 billion years ago, a vast cloud of gas and dust floated through the galaxy we call the Milky Way, the ghostly remains of a great star that had died in a gigantic explosion. The gas and dust is twisted and shaped by magnetic forces, electrical currents, and the subtle pull of gravity. As it swirls around a thickening core, the huge cloud gradually flattens into a disk. Dust and gas gravitate slowly inwards, and eddies begin to form in the cloud. Particles of matter cluster into solid bodies. The larger bodies continue to grow, sweeping up particles and dust as they orbit the condensing core of the disk and begin to heat under the increasing gravitational pressures. In the central core of the disk, incredible heat is being generated, hotter and hotter, until it reaches critical temperatures. And then, billions of years ago, a nuclear reaction occurred, and our sun was ignited. Its intense radiation repels the surrounding gas and dust. The increasing heat of the inner planets has formed them into molten spheres. Mercury, like the other inner planets, is continuously bombarded by debris that form craters on its surface. In the final stages of its formation, Mercury glowed from internal heat. Hot lava was forced to a surface being torn by collisions with masses of rock that were shaping the planet. The same heat that triggered the lava flows also melted rock and metals in the interior of Mercury. Heavy iron concentrated at Mercury's center to form a dense core, which was overlain by a thin shell of lighter material brought to the surface by lava flows. Again, the surface was gouged and pitted by a great series of impacts, leaving huge craters on the surface. The Mariner 10 photographs have revealed these early craters to scientists for the first time. One of these craters was formed by a massive rock, perhaps a small planet that crashed into Mercury. In the Mariner 10 photographs, half of this huge crater was hidden on the night side of the planet. Today, this huge crater is called Colorus. The impact spewed millions of tons of debris across the surface of Mercury, creating a ring of mountain ranges over a mile high. The floor of this basin was split by great surface cracks, wide and deep. As this surface continued to form, deep inside Mercury, its heavy iron core began to contract. The surface buckled, cracked, and great sections, hundreds of miles wide, were split open, leaving immense mile-high walls of rock called scarps. Again, there was a great flow of lava covering many of the large craters and leaving smooth, flat plains. This set the stage for the final episode in the history of Mercury, a period of light cratering of the Great Plains. In this time, Mercury died. The internal heat that triggered many of the events in the planet's history turned off. And for 3.5 billion years, Mercury has remained as we see it today.
Before Mariner 10, there were a multitude of possible Mercuries. Now there's only one, the Mercury of craters and basins and plains. And this illustrates how photography can be an exploratory tool. It displays features which were perhaps never even anticipated and then sometimes could not even be imagined before the experiment was flown. In a sense, it provides answers to questions that were not even asked. This was true at Mars when Mariner 4 returned pictures of what appeared to be a moon-like surface. It had been expected that Mars might be very much like the Earth, with folded mountain ranges and many other Earth-like features. Instead, it looked like the moon, and that was a big shock. And it was an even bigger shock when Mariner 9 in 1971 visited Mars again and found huge volcanoes and even some peculiar sinuous channels that looked like they might have been formed by flowing water at some point in Mars's history. Now Viking has transported man's vision to the actual surface. The fantasy of science fiction has been replaced by the strange, lonely reality of the Martian landscape. When Mariner 10 flew by Venus, it discovered an unexpectedly well-organized set of cloud motions. And the unexpected was certainly encountered in the case of Mercury, which turned out to exhibit not only moon-like features on its surface, but a sequence of events there that seemed to be very similar to those of the moon. And that's extraordinary, because Mercury is very different inside compared to the moon. And that means it must have had a different history of heating and modification of the surface from the inside. And furthermore, it lives in a very different part of the solar system, much closer to the sun. And therefore, it must have experienced a different exterior history as well. And yet, the pictures show that Mercury has a surface history very similar to that of the moon. And to me, that's extraordinary.
A comparison of the craters on the moon, Mercury, and Mars shows that these inner planets were subjected to cratering at the same time. Before Mariner 10, it was believed that the source of cratering of the inner solar system was the asteroid belt orbiting beyond Mars. Because of the difference in distance from the belt, it was assumed that no two planets would be cratered the same. Those planets farther from the asteroid belt, like Mercury, would have fewer craters. But a careful count of the craters on Mercury and a comparison with those on the moon and Mars showed them all to be roughly equal. If the crater count is equal, then the source could not be the asteroid belt, but must have come from elsewhere in the solar system. One strong possibility is the planet Jupiter, with a gravitational attraction second only to the sun. It is possible that on 2 occasions, Jupiter literally hurled millions of tons of rock inwards towards the sun to impact the planets of the inner solar system, including Mercury. This cratered record on Mercury was read 3 times because of a fortunate coincidence. Mercury's orbit around the sun is 88 Earth days. Mariner 10's orbit was twice as long, or 176 days. These synchronous orbits allowed Mariner 10 to fly past Mercury a second and third time. The path of the first flyby was on the dark side of Mercury. The second encounter sent the spacecraft past the light side of the planet specifically for photography. After another 6-month journey around the sun, Mariner 10 made its third and final encounter to look again at a major discovery made during the first flyby: the presence of a magnetic field around Mercury, similar to Earth. A bow shock wave blocks the solar wind from the sun and deflects it around the planet, creating an environment similar to the magnetic field around Earth. This discovery was a surprise because Mercury's slow rotation, about once every 57 Earth days, had led scientists to believe that the planet could not generate a magnetic field. It is believed that Earth's magnetic field is generated by an interaction between the planet's faster rotation and its molten core. Mariner 10's discovery may change theories on how these fields are formed and has given scientists their first opportunity to compare 2 magnetic fields in the inner solar system. There were other measurements made at Mercury by Mariner 10. Infrared showed that Mercury's surface ranges in temperature from 700 degrees Fahrenheit to 300 degrees below zero, the widest temperature range of any planet. The ultraviolet experiment revealed that Mercury has a very thin atmosphere of helium. Sensors measured the invisible cosmic rays which flood our solar system at tremendous speeds, penetrate any surface, and are unaffected by gravitational forces. Their source is unknown.
Exploration is an adaptive process. Each new piece of information adds to the value of others that were accumulated earlier. We had the results of the Apollo program on the moon to help us understand the timescales and to some extent the processes we were seeing when we looked at Mars with Mariner 9. Now that Mariner 10 has looked at Mercury, we can begin to compare it with the moon and Mars and begin to realize that there is a common solar system history which has been recorded on these planets, whose early surfaces have not been erased by erosion and other atmospheric processes. That same common history affected the Earth too. And so by looking at these surfaces, reading those records, we're in fact looking back into the Earth's history, into a heretofore unexplored domain of time, our own history on the Earth. Now we can begin to compare and contrast, to look for similarities and differences, and try to recognize our family relationships among the terrestrial planets. Are we cousins or brothers? Or are all of us bizarre strangers that happen to inhabit the same portion of the solar system? That's the task of comparative planetology. That's where we go from here.
In future planetary flights, Venus will be explored once again. The probes of one Pioneer spacecraft will penetrate its thick atmosphere, while a second Pioneer orbits the planet. Two Mariner-class spacecraft will explore the planet Jupiter, and then fly outward to reach Saturn. One of the Mariners may be sent on to the planet Uranus, over 1.5 billion miles from the sun. And someday in our future, we will send intelligent machines, robots, to explore the hostile surface of Mars, and perhaps even the ancient moons of Jupiter.